Precambrian rocks fascinate me far more than the more modern stuff.
A little bit about our July 3rd, July 4th trip to Trout Lake, just north of Sault Ste. Marie in Ontario. This is about where the location is. So, it's no big secret. There is something interesting about the fact that this lake trends east-west and this island in the middle. It is out of place. We'll come back to that in a little bit here. So we get out there on the 3rd. Mike Doyle picks us up. He owns the island and a bit of property on the north side. And so clear. The water's like a mirror. And it kind of messes with you when it's like this. It really does. But you can see the rocks dipping into the water to the left. They didn't fall that way. That's their natural position. The rocks here typically dip to the southwest 30 to 45 degrees, something like that. That's the actual dip of the beds. And a lot of these cliff faces are close to that. And they also seem to form this unique weathering pattern, which Mike wants to write a paper about because we don't really see this anywhere. You just see the loose boulders around the rim of the island. And this would actually be a good indicator to see if it's underwater to these things, to see if maybe there were shallow shorelines. Now, there's a lot of things here out of place. Most of the ridges trend slightly northwest, which is kind of not the opposite, but at a great degree difference from the glacial striations, which are mostly southwest. So there's no way the glaciers carved this out. We'll come back to that later.
Got tumbled down. It's just like a giant field of chunks of rock. See this amazing shoreline I'm talking about, like freeze fracture.
Yeah, it's all
Shelf. We'll come up with some.
sort. I'll let you pick. I'll just.
So we could, if we wanted to come back here, we could probably pull the boat up along the side and jump up on that slab if you're interested.
Now, we first stopped at the west side of the island, and the slope there is about 40 to 50 degrees, so you can't get on the side of it without sliding, and it's a straight drop down into the water, and I didn't want to end up having to be pulled out. So we did what we could from up top, took some measurements, and then we got on our way.
Yeah, that's why you need them.
Take a picture.
And he asked me, Steve, how do you think this lake formed? And I said, I think it's an old river system from east to west, eventually becoming dammed by the glaciers to the west. And on the south side of this lake, it's very deep, a few hundred feet, so about 100 meters or so. On the north side, it's not that deep. That's where all the islands are, other than the big island. And on the east side, it's really shallow, which we'll come back to. So this thing is odd. I think if you were to come here 3 million years ago, you would have seen a series of waterfalls into this canyon here and a river heading out west into the Lake Superior Basin, which probably more than likely existed pre-glacial times as probably a lake. It's probably the only one of the Great Lakes that was a lake before the glaciers came through. Now, as I said, the glaciers kind of just overrid this landscape. They did dig out a little bit.
No, we thought there was another piece, but I can look at pictures.
Wow,
Isn't that great?
it is. Some of that looks like it's on its way out too. So you need to name the cliff face. Name it.
One of the main goals of this trip was to try to figure out the lithology of the Ayers Formation, because it's been traditionally thought of as a fault-bounded alluvial fan system. Now, not on the island and not around the island on the main shore, but to the west. We didn't go east, but we went west. And there is some conglomerate near the base. I didn't find the contact with the underlying Archean granitoids. And McConnell in 1927 described this stuff really well. He's really the only one that ever bothered. And he also named the Ayers Formation, named a couple other units which now have different names. So if you don't know what you're reading, you're going to get confused.
No, you need a sign to say heavy trucks encouraged. Oh.
I don't think there are any fault contacts. I personally think this was some sort of restricted basin during the Huronian. time. Now, Huronian is an actual supergroup, but I'm just going to use it generically to talk about time, even though it's not technically correct. But basically, during when the Huronian deposition, the continent rifted. Something to the south broke off, and we got these massive passive margin sequences with glacial deposits between. And thin glacial deposits, except the Gauganda is a little thicker, but most of the deposits are sandstones, indicating semi-arid environment. Remember, only thing living then was stromatolites and other bacterial forms in the ocean. We had nothing on land then. Most of these deposits are analogous to any modern sandy coast, not near a mountain range, a passive margin, like the east shore of North America, essentially.
That's the poo unit? Yeah. Is that the technical term for it? The poo unit?
Giant section of the island, just like what you're saying. So probably in no time you'd start getting invasive, just like exactly what you said, even from birds or whatever.
Okay.
But within a natural system, you generally don't get too many invasives, just because.
Okay.
So we went back after having such a great day and taking a lot of measurements. And we came back the next day, and you can see here it says 89 degrees. This is in Fahrenheit. It was more like 93, the high, which is about 33 degrees centigrade. It was hot. The day before was hotter. Today is even hotter, the 4th. There's basically 2 maps this area, and one of them only has the east part of Trout Lake, and it's in black and white, and it has this dike on it, which I went chasing and didn't find, but we'll come back to that. And you look at the color map from 2006, and it just shows a bunch of faults around it, and Awards is this brown splotch. Now, that's typically done when people can't figure out the geology of rocks this old, 2.5 to about 2.2 billion years old with a B.
There's some striations. We could have had a grindstone or something right here. This pit looks natural. Striations here. Let's get these first. Look at us.
The striations are really clear in some of these faces. So we get to the south central side of the island, which is where this dike was originally mapped. And I try to chase this thing. Mike goes way ahead of me. And I can't find it. I do find some things, though.
There's somebody's eggs. I don't know whose. Yeah, I think Mike's down. I thought might be a mafic dike here. That was the whole point. And maybe knock some of this off. But it's all metaarchos. No, it is not concrete. Very typical of the conglomerate. Cool structures there. I think it's bedding. And then this is on its side. See the conglomerate there.
It was hot. And I'm chonky as it is, but I can hike up ridges. You just gotta wait for me. And actually, I can still out hike a lot of people who are not as big as me. But when it's this hot, man, it just kicks my butt. And Mike's a great person, and he's excellent to hang around with, and I can't wait to go back there. When we got back into the boat, I start taking GPS coordinates as we go along the south shore to the east, just trying to figure out if there is this dike, one where an entrance might be. And only the last one seemed promising. So if there is some sort of igneous intrusion here, I think it's probably this last location. Now, we did do some stuff which is not in this video, and that's talk for another time, a more geology-focused one. But after that, we went over to the east side of the island where the sand is, and here I'm speeding everything up for you. So,
and this under us is all, there's a massive amount of sand. This is all sand coming from. And when you look on a map, I can't really tell what's going on. I mean, it just looks like more of the same. But there must be some massive deposit of sand someplace back here, and it probably has to do with the previous system. easier.
Yeah.
Have you ever been down there on a kayak?
Yes. You can go down a ways and then you hit a beaver dam.
Oh,
And it's cool because you're on the water in a kayak and the beaver dam is like 6-8 feet high.
yeah, that was super pretty.
Now this beach I would hang out at, and I would go in this water. You can walk all the way out here. It's- I know.
Roll the sand is coming.
Where does it start to drop off? Well, you can still totally walk on this here. I mean, you can totally still see it.
And I bet this place was really beautiful to stand at before the glaciers dammed it up and created this lake. The lake's still beautiful, don't get me wrong. And I cannot wait to go back here. I really can't. And it was fantastic. It was a great time, and I really want to go back. Anyway, I think that's it. I hope you guys learned something. You know, if you want to leave a comment or something, go ahead, ask me some questions. And here's a little bit of Zen for you on the way out. See you next time.